Applications such as email, web browsers, and instant messaging clients enable people to use computers and networks to send messages and find information. Data from each of these applications is packaged, transported, and delivered to the appropriate destination device. The transport layer of the OSI model is responsible for the overall end-to-end transfer of application data. This video presents the transport layer mechanisms, services, and protocols that support this end-to-end connectivity. The primary responsibilities of the transport layer include tracking the individual communication between applications on the source and destination hosts, segmenting and reassembling the segments into streams of application data, and identifying the different applications associated with data. In this graphic, the user is working with many applications simultaneously. These include email, instant messaging, multiple web pages, IP telephony, and streaming video. Each type of traffic is represented by a different colored arrow. The transport layer maintains these communication streams by dividing the application's data into small parts called segments and interleaving these segments across the network media. To identify each segment of data, the transport layer adds a header to each segment that contains a unique number. These numbers are also used for reassembling the segments at the destination host. Protocols at the transport layer enable connection-oriented conversations by establishing a session between source and destination hosts before the data is transmitted. Reliable delivery is assured because the data is resent if it becomes corrupted or is not received by the destination. Ordered data reconstruction means that data is delivered to the application in the proper sequence. Flow control ensures the sending and receiving devices are communicating at a mutually agreed-upon rate. The two most common transport layer protocols of the TCP/IP protocol suite are Transmission Control Protocol, or TCP, and User Datagram Protocol, also called UDP. Data such as email and web pages require that all of the data sent arrive at the destination in order to be useful. Any missing data could cause a corrupt communication that is either incomplete or unreadable. Therefore, these applications must use a transport layer protocol that is reliable, as is TCP. Other applications, such as IP telephony and streaming video, are more tolerant of the loss of small amounts of data. For example, if one or two segments of a video stream fail to arrive, it would only create a momentary disruption in the stream. This may appear as a distortion in the image, but may not even be noticeable to the user. These applications must use a transport layer protocol that has low overhead and is fast, as is UDP. Let's look at how a TCP conversation is established. TCP is a connection-oriented protocol, which means that when two hosts communicate, a connection is established using a three-way handshake before data is transmitted. First, the initiating client sends a TCP segment containing an initial sequence value, which serves as a request to begin a communication session with the destination host. Next, the destination responds with a segment containing an acknowledgement value equal to the received sequence value plus 1. This acknowledgement value enables the source client to tie the response back to the original segment that it sent to the destination. At the same time, the destination sends its own synchronization sequence value. Finally, the initiating client responds with an acknowledgement value that is equal to the sequence value it received plus 1. After this process of connection establishment, data can be sent. After the communication is completed, the sessions are closed and the connection is terminated. TCP is a reliable transport protocol. This seems like a good thing, but the overhead included in TCP makes it a poor choice for applications such as IP telephony and video, which require near real-time delivery of packets. UDP is a simple protocol that provides only basic transport layer functionality. As you can see, the header information added to upper layer data by UDP is smaller than that added by TCP. UDP is not connection-oriented and does not provide the sophisticated retransmission, sequencing, and flow control mechanisms that are provided by TCP. This does not mean that applications that use UDP are always unreliable. It simply means that these functions are not provided by the protocol and must be implemented elsewhere, usually at the application layer if required. Data networks and the Internet support the human network by supplying seamless, reliable communication between people, both locally and around the globe. You can see how important the transport layer is to this communication. As you continue the study of networking, you will appreciate how understanding the transport layer, specifically TCP and UDP, contributes to designing, supporting, and troubleshooting reliable and secure networks.